In this video, we're going to talk about how to use the superposition theorem in order to solve circuits. So in this problem, we have a ground at a potential of 0. Use the superposition theorem to determine the potentials of point A and B with respect to ground, and also to determine the amount of current flowing through each resistor. In short, solve for everything in the circuit. Now, the basic idea behind the superposition theorem is that what you want to do is you want to calculate the voltages and the currents in each circuit by taking into account just one power source alone. So while using the 60-volt power source, you would remove the 5 amp current. And then when analyzing the circuit with the 5 amp current, you would remove the 60-volt power source. And then you would combine these two circuits and take the algebraic sum of either the voltages or the currents, and that will give you the answer. So let me show you that through an example problem. Let's analyze the circuit with the 60-volt battery first. So we're going to eliminate the 5 amp current source. When removing a current source, you need to replace it with an open circuit. When removing a voltage source, you need to replace it with a short circuit. So just keep that in mind. So let's put an open circuit here. Now let's calculate everything in this circuit with the 60-volt battery. So notice that these two resistors are in series with each other. So that's 12 plus 8, that's 20. Now the 20 ohm resistor, that is these two, they're parallel to the 4 ohm resistor. To calculate the equivalent resistance of those two resistors, it's 1 over 20 plus 1 over 4 raised to the minus 1. Now, 1 over 4, if you multiply that by 5 over 5, that will give you 5 over 20. And so this is 6 over 20. And then when you raise it to the minus 1, it becomes 20 over 6, which is 10 over 3. And of course, you can type this in your calculator to confirm that. So these three resistors have an equivalent resistance of 10 over 3. And then we have the 5 ohm resistor in series with that. So the total resistance of this circuit is 5 plus 10 over 3, which is 8.3 repeating. So now that we have the total resistance, we can now calculate the current flowing from the battery. So it's going to be the voltage of the battery divided by the total resistance. So that's 60 volts divided by 8.333 repeating. And this will give us a current of 7.2 amps. Now that we have the current flowing through the 5 ohm resistor, we can calculate the potential at A. The potential at A is going to be the potential of the battery, 60 volts, minus the voltage drop of the 5 ohm resistor. So the voltage drop is going to be the current flowing through it times the resistance. So 60 minus 7.2 times 5, that's going to give us a potential of 24 volts. So that is the potential at point A. Now we can also calculate the current flowing through the 4 ohm resistor. So that current is going to be the voltage across the 4 ohm resistor divided by the resistance. The voltage across it is 24 volts divided by 4 ohms. And so that gives us a current of 6 amps flowing in that direction. Now, if we subtract these two currents, 7.2 minus 6, that'll give us the current flowing from point A to point B, which is 1.2 amps. Next, we can calculate the potential at point B, which is going to be the potential at point A minus the voltage drop across the 12 ohm resistor. So the potential at point A is 24 volts minus 1.2 times 12. And so the potential at point B is 9.6 volts. And if we divide 9.6 by the 8 ohm resistor, we're going to get this current, 1.2 amps, flowing through the 8 ohm resistor. So that tells us that our numbers is good, our math is good rather. So we're done with the first part of the problem. But the data that we need to keep right now is the potential at point A and B. So I'm just going to rewrite that here. So the potential at A for the first part of the problem is 24 volts, and the potential at B for the second part is 9.6 volts. Now, just to compare it with the currents, I'm going to write the current through the 4 ohm resistor. The current flowing through that is 6 amps. We're going to use that later. So now let's just get rid of this so we don't have to redraw the circuit. Now what I'm going to do now is introduce the 5 amp current source that we had at the beginning. So let's put the current here, and now we're going to get rid of the voltage source. So we replace the current source with an open circuit. We're going to replace the voltage source with a closed circuit or a short circuit. So now that we've replaced the voltage source with a short circuit, let's see if we can calculate the potentials at A and B, and also the current flowing through the 4 ohm resistor. So right now we can clearly see that the 5 ohm resistor and the 4 ohm resistor are parallel to each other. And they're in series with the 12 ohm resistor. And then these 3 resistors are parallel to the 8 ohm resistor. So let's do the math. So we have 1 over 5 plus 1 over 4 raised to the minus 1, and then we're going to add 12 to that. 1 over 5 plus 1 over 4 raised to the minus 1, that's 20 over 9, which is 2.2 repeating. And then adding that to 12, that's 128 over 9, which is 14.2 repeating. Now, the 14.2 ohm resistor is parallel to the 8 ohm resistor. Well, actually, we don't need to find the equivalent resistance for that. There's no point of that. But here's what we do need to do. What we have here is a current divider circuit. One of the resistors is 8 ohms, the other resistor is 4.2 repeating. And we have a current of 5 amps flowing through this current divider. To calculate the current flowing through the 8 ohm resistor, it's going to be 5 amps times the other resistor divided by the sum of the two, which is 8 plus 14, that's 22, but 22.2 repeating. So this will give us a current of 3.2 amps. So if 3.2 amps is flowing through the 8 ohm resistor, then 5 minus 3.2, which is 1.8 amps, that has to be flowing through the 14.2 ohm resistor. So now let's follow the current. So we have 5 amps of current in this direction. 3.2 is going to go towards the 8 ohm resistor. And then the difference, that is 1.8, is going to flow here. Now we need to see how this current is going to split apart. So we need another current divider system. So when it splits off, there's two resistors that we need to consider. That is the 4 ohm resistor and the 5 ohm resistor. And we have 1.8 amps of current entering that network. So if we take 1.8, multiply it by 5, divided by the sum of the two resistors, 4 plus 5 is 9, we're going to get 1 amp. So 1 amp of current is going to flow through the 4 ohm resistor, and then the difference between 1.8 and 1 is 0.8. That's going to flow through the 5 ohm resistor. And it makes sense. There's going to be more current flowing through the resistor that has a lower value, and less current flowing through the part that has, more resistance. So then we have 1 amp of current flowing towards point A, and then the other 0.8 amps is going through the 5 ohm resistor towards point A. So at this point, we can now calculate potentials. So what is the potential at point B? Will it be greater than or less than 0 volts? Because the current flows from the ground to point B, the potential at point B is going to be less than 0 volts because conventional current flows from a high potential to a low potential. So the potentials at point A and B will both be negative. It's important to understand that relative to the ground. So to calculate the potential at point B, it's going to be 8 times 3.2. But it's going to be negative though. And so that's going to be negative 25.6 volts. So I'm going to write that here. Now to calculate the potential at point A, it's going to be, the voltage is going to equal IR. The voltage is the potential difference between the ground, which is at 0 volts, minus the potential at A, and that's going to be IR. So VA is going to equal negative IR, for those of you who want to see why it's negative. So it's negative times 1 times 4 ohms. So the potential at A is negative 4 volts. Now the current through the 12 ohm resistor is going to be in this direction. It's going to flow from A to B because A is at a higher potential than B. A is less negative. Now if we want to calculate the current flowing through the 12 ohm resistor, it's simply the sum of these two currents. So it's 1.8. But we don't need that. But let's write down the information for the second part of the problem. The potential at A is negative 4 volts. The potential at B, which I need to write here, is negative 25.6 volts. And the current flowing through the 4 ohm resistor is 1 amp. But notice that the direction is opposite to the direction in the first part of the problem. The current was going this way, it was 6 amps. But now the current's going in the other direction. So we're going to say that it's negative 1 amps, since it's going in the opposite direction to where it was going in the first part of the problem. So now let's get rid of these numbers, because once we combine the first part and the second part of the problem, they're going to change. So now let's reintroduce the battery back into this problem. So now using the superposition theorem, to get the potential at point A and B, we need to add the potentials from the two problems. So the potential at A was 24 volts in the first part of the problem and negative 4 volts in the second part of the problem. So with the two power sources being present, the potential at A is now going to be 24 plus negative 4 volts. So this is going to be 20 volts. The potential at B is going to be the sum of these two. So it's 9.6 plus negative 25.6, which is just 9.6 minus 25.6, and that's going to be 16 volts. But not positive, but negative 16 volts. Now the current flowing through the 4 ohm resistor is going to be the sum of these two. So it's 6 plus negative 1, so we should get 5 amps, and we could use that to check our work. And we can clearly see that this is going to be correct because 20 volts divided by 4 ohms will give us a current of 5. And the current is flowing in this direction, which is the same direction as the 6 amp current in the first part of the problem. Now let's go ahead and calculate the currents flowing through the other resistors. For the 5 ohm resistor, the current is going to be the voltage across it divided by the resistance. So the voltage across the 5 ohm resistor is going to be 60 minus 20. So there's 40 volts across it divided by 5. That means that we have a current of 8 amps flowing through it. Now out of those 8 amps, 5 amps went down to the ground. That means the other 3 amps is flowing through the 12 ohm resistor. And it makes sense. 20 volts minus 3 times 12 will give us a potential at point B, which is negative 16. And then negative 16 divided by 8 gives us a current of negative 2 amps. Now the current is going to flow from a high potential to a low potential. So it's going to be flowing towards point B. So we have 2 amps flowing in that direction. Now we can confirm the currents here because we have 3 plus 2, which adds up to the 5 amp current flowing in this direction. Now once we reach this point here, 2 amps out of the 5 amps will go upward. That means at this point we have 3 amps of current flowing towards the next node. Now at this node, the 5 amp current meets up with the 3 amp current, which will regenerate the 8 amp current that is flowing towards the battery. And so these two, they must be the same. So now we have everything solved in this circuit. We know the potentials at each point, and we know the current flowing through each resistor. So that's the basic idea behind the superposition theorem. What you do is you solve the circuit with one power source at a time, and then you can add up all the potentials from each solved circuit from each power source that you calculated. And then once you add them up, you can solve the combined circuit now. So that's the basic idea behind the superposition theorem. The voltage or the potential produced by each power source can be added to get the potentials when all of the power sources are combined. Now let's try solving another example problem. This time with 3 power sources. We have 2 current sources and 1 voltage source. So go ahead and use the superposition theorem to calculate the potential at each point and the currents flowing through each resistor. Now for this particular problem, we're going to focus on 2 points of interest. That is, those 2 points. If we can calculate the potential at point A and at point B, we're going to have everything we need to solve the entire circuit. So let's start with the 4 amp current source. We're going to replace the 60 volt power source with a short circuit, and we're going to replace the current source with an open circuit. So we know that we have 4 amps of current flowing through the 5 ohm resistor. Now, these two resistors are parallel to each other. And then those two resistors combined are in series with the 3 ohm resistor. And then this entire network, well, we'll leave it at that for now. Let's calculate the equivalent resistance of these 3 resistors. So it's going to be 1 over 3 plus 1 over 4 raised to the minus 1, and then plus 3. So you should get 4.7143 ohms for the equivalent resistance of those 3 resistors. So I'm just going to rewrite that here. So now, using our current divider circuit, so once the 4 amp current reaches point A, it has 2 ways it can go. It can go through the 6 ohm resistor, or it could travel through this network with an equivalent resistance of 4.7143. So to calculate the current flowing through the 6 ohm resistor, it's going to be 4 times 4.7143 divided by the sum of those 2 resistors. So 6 plus that number, that's going to be 10.7143. So I got a current of 1.76 amps flowing through the 6 ohm resistor. Now, taking the difference between these two numbers, so 4 minus 1.76, that's going to give us the current flowing through the 3 ohm resistor. So that's a current of 2.24 amps. So now that we have that current, we can calculate the current flowing through the 4 ohm resistor and the 3 ohm resistor. So it's going to be the current entering that network, which is 2.24 amps, times the 4 ohm resistor, divided by the sum of those two, which is 7 ohms. And so that's 1.28. So thus we're going to have a current of 1.28 amps flowing through the 3 ohm resistor. And then 2.24 minus 1.28, we're going to have a smaller current flowing through the larger resistor. So that's 0.96 amps. So at this point, we have everything that we need to calculate the potentials at point A and B. So to calculate the potential at point A, where the ground is set to 0 volts, it's just going to be 1.76 times 6. So the potential at A with respect to ground is 10.56 volts. And the potential at B with respect to ground, you can multiply 1.28 times 3 or 4 times 0.96. Since those two resistors are parallel, the voltage across them should be the same. And you get 3.84 volts. So that's the information we have from the first power source. So now let's just get rid of this. And let's focus on solving the circuit with the second current source. So this was the 3 amp current source. Now this current has no choice but to flow through the 5 ohm resistor. So we got 3 amps flowing through that resistor. Now let's pause and think about the direction of the current flow in this circuit. So once the 3 amp current reaches point A, it can go through the 6 ohm resistor or through the 3 ohm resistor. But we need to think about its destination. Its destination is point B. It needs to go back to where it came from. So once it flows through the 6 ohm resistor, the current will go here, back up through the 3 ohm resistor, and through the 4 ohm resistor to point B to get back to where it came from. So in order to determine the equivalent resistance, we need to redraw this circuit. So it's starting from point A and it wants to get to point B. Now between point A and B, we have a 3 ohm resistor. So that's one path going from A to B. It could just go through the 3 ohm resistor. Another way it can get to point B from point A is it has to go through the 6 ohm resistor first. So I'm going to draw that here. And then from the 6 ohm resistor, it can go through the 3 ohm resistor, and that'll take it to point B. Or, after going through the 6 ohm resistor, it can go through the 4 ohm resistor to get to point B. So with respect to points A and B, we need to put these two resistors in parallel and then add it to the 6 ohm resistor. So the 3 and 4 are parallel to each other, and they are in series with the 6 ohm resistor. So it's going to be 1 over 3 plus 1 over 4 raised to the minus 1 plus 6. So the equivalent resistance, let me do that again. The equivalent resistance of these 3 resistors is 7.7143 ohms. So now we can set up our current divider circuit. So going from point A to point B, there's 2 options. The current can flow through the 3 ohm resistor, or it can flow through an equivalent resistance of 7.7143 ohms. And we have 3 amps of current entering this branch. So we can get rid of this at this point. So to calculate the current flowing through the 3 ohm resistor, it's going to be 3 amps times the other resistor divided by the sum of those 2 resistors, which is 10.7143. So the current flowing through the 3 ohm resistor is going to be 2.16 amps. And if we take 3 and subtract that by 2.16, we'll get the current flowing through the 6 ohm resistor, which is 0.84 amps. So at this point, we have everything we need to calculate the potential at point A. The potential at point A with respect to ground is simply the voltage drop across the 6 ohm resistor. So it's 0.84 times 6 ohms. And so the potential at point A is 5.14 volts. Now we can calculate the potential at point B now that we know the current flowing through the 3 ohm resistor. So it's the potential at point A, which is 5.14, minus, keep in mind that the current flows from a high potential to a low potential. So potential B is lower than potential A. So it's 5.14 minus the voltage drop across the 3 ohm resistor. So that's 2.16 amps times 3 ohms. And I made a mistake. This shouldn't be 5.14. That should be 5.04. 0.84 times 6 is 5.04. I'm not sure why I added the 1. But 5.04 minus 2.16 times 3 gives us the potential at B, which is negative 1.44 volts. Now this answer makes sense because, as we said before, current flows from a high potential to a low potential. 0 volts is at a higher potential than negative 1.44. So we can see the direction of the current flow through the 3 ohm resistor, and that is that it's going up and not down. And if we want to calculate the current flowing through the 3 ohm resistor, it's 1.44 volts divided by 3 ohms. And so that's 0.48 amps. The current flowing through the 4 ohm resistor is 1.44 divided by 4, which is 0.36 amps. And these two currents, 0.48 plus 0.36, adds up to 0.84. So far, everything makes sense at this point. So now let's clear away the extra information that we don't need anymore. And let's remove this current source. And let's reintroduce our voltage source. So go ahead and solve this circuit. Calculate the potentials at point A and B due to the 60 volt voltage source. So we can clearly see that there's not going to be any current flowing through the 5 ohm resistor because there's no path for the current to flow. So we could ignore the 5 ohm resistor. So relative to the voltage source, we know that the current is going to flow this way through the 3 ohm resistor back to the negative terminal, and it's also going to flow through the 3 ohm resistor and the 6 ohm resistor in that fashion. So that's the direction of the current in this part of the problem. So right now, the 3 ohm and the 6 ohm resistor are in series with each other. So that's an equivalent resistance of 9 ohms. So the current can flow through in this direction, or it can flow through this direction. So the 3 ohm resistor here is parallel with the 9 ohm resistor. So we have 9 parallel to 3, and the 4 ohm resistor is in series with this equivalent resistance. So we're going to add 4 to it. To determine if a resistor is in series or in parallel, it all depends on how the current is flowing. So the current flows through the 4 ohm resistor. Then it splits off into 2 directions. It can go in this direction or in that direction. So because there's only one path for the current to flow through these 2 resistors, they are in series with each other. That's why we can add them and get 9. But at point B, there's multiple paths for the current to flow. So that's why this equivalent resistance is in parallel to that one. But through the 4 ohm resistor, there's only one path for the current to flow. So that's why the 4 is in series with this entire network. So that's how you can tell which resistors are in series and which ones are parallel to each other. It's based on the flow of the current. If there's only one path for the current to flow, the resistors are in series. If it can split off into multiple paths, then those resistors are in parallel with respect to each other. But let's calculate the total equivalent resistance across the 60 volt battery. So it's going to be 1 over 9 plus 1 over 3 raised to the minus 1 plus 4. And so you should get a total resistance of 6.25 ohms. Now, to calculate the current flowing from the battery through the 4 ohm resistor, it's the voltage of the battery divided by the total resistance across the battery. So it's actually 60 volts rather. 60 divided by 6.25 ohms. So the current flowing through the 4 ohm resistor is 9.6 amps. So now that we have that, we can use a current divider network to determine what the next current will be. So we have 9.6 amps entering this area, and it can flow either through the 9 ohm resistor, or it can flow through the 3 ohm resistor to get back to the negative terminal of the battery, or to get back to ground. So let's calculate the current flowing through the 3 ohm resistor. It's going to be 9.6 amps times the other resistor divided by the sum of them. So it's 9.6 times 9 over 12. Thus we get 7.2 amps flowing through the 3 ohm resistor. And 9.6 minus 7.2, that's 2.4. So we have 2.4 amps flowing towards point A, and also flowing through the 6 ohm resistor. So now we can calculate the potentials at point A and at point B. So to calculate the potential at point B, it's going to be the voltage of the battery, 60 volts, minus the voltage drop across the 4 ohm resistor. So that's 4 times 9.6. So the potential at point B is 21.6 volts. To calculate the potential at point A, there's two ways we can do it. We could take the potential at point B and subtract it by the voltage drop across the 3 ohm resistor. So it's going to be 21.6 minus a current of 2.4 amps times the 3 ohm resistor. And so that's going to be 14.4 volts. The other way to get the same answer is to multiply 6 by 2.4. And we'll also get 14.4 because the potential at the ground is 0. So now that we have the potentials at A and B for each of the 3 power sources, we can now complete the problem. But first, let's clear away any extra information that we don't need right now. And let's rewrite the current sources. So this was a 3 amp current source, and that was a 4 amp current source. Now what we're going to do is we're going to add the potentials at point A and point B. So the potential at point A is 10.56 plus 5.04 plus 14.4. So according to the superposition theorem, when putting all 3 power sources in a circuit, the potential at point A should be 30 volts. And at point B, it's going to be 3.84 minus 1.44 plus 21.6. And so the potential at point B is 24 volts. So now that we know the potentials at A and B, we can calculate all the currents flowing in the circuit? Well, we know these two currents have no choice but to flow through the 5 ohm resistor. So we have 7 amps of current flowing through the 5 ohm resistor. Thus, we can calculate the potential at this point. 7 times 5 is 35. So we have a voltage drop of 35 at the 5 ohm resistor. And if we call this point C, the potential at point C is going to be 35 volts higher than the potential at point A. So that's going to be at 65 volts. Now the current flowing through the 6 ohm resistor is going to be 30 volts divided by 6. So it's 5 amps. Now 7 minus 5 is 2. So there's 2 amps of current flowing through the 3 ohm resistor. And it makes sense because 2 times 3 gives us a voltage drop of 6. And 30 minus 24 is equal to 6. Now to calculate the current through the 3 ohm resistor, it's going to be 24 volts divided by 3 ohms. So that gives us a current of 8 amps. Now let's focus on point B. So at point B, we have 4 lines, so to speak. So we have 2 amps of current flowing towards point B. We have 8 amps of current flowing away from point B. And there's a current source of 3 amps, so the current here has to be 3. What is the current that is flowing from the battery through the 4 ohm resistor? Let's call this I1, I2, and I3. So we could use Kirchhoff's current law to get the answer, which states that the sum of the currents flowing into or out of a node or a point adds up to 0. Now what we need to do at this point is assign positive and negative values. So let's say that the current flowing into the point, we're going to give it a positive value, whereas the current leaving point B, we're going to give it a negative value. That means that I2 and I3 should be negative because those currents are moving away from point B. So I1 is positive 2, I2 is negative 8, I3 is negative 3, and so we can now calculate I4. So it's 2 minus 8 is negative 6. Negative 6 minus 3, that's negative 9. So moving the negative 9 to the other side of the equation, we can see that I4 is 9 amps. That's one way in which you can get that current. The other way is to use Ohm's law. Take the voltage across the resistor divided by the resistance, you can get the current. The voltage across the resistor is the potential difference across it. So we have a potential of 60 volts on one side and a potential of 24 on the other side. So we have a voltage of 36 volts across the 4 ohm resistor. 36 divided by 4 gives us the same current of 9 amps. So now we know the current flowing through each resistor, and we also know the potentials at every point. The potential at, let's call this point D, is 60 volts. It's just the voltage of the battery. So that's it for this video. Now you know how to use the superposition theorem to solve circuit problems that contain multiple voltage and current sources. Thanks for watching.